Hey there, and welcome to This Explainer. You know that feeling when you look at a math problem covered in those tiny, floating numbers and your brain just kind of freezes? Yeah, if you've been there, you are absolutely in the right place. I know those little numbers, indices, or exponents, can look incredibly intimidating at first glance. But I promise you, they aren't magic, and they definitely aren't trying to trick you. They're actually just really simple, logical shortcuts. Think of me as your personal tutor today. We're going to walk through this together, completely step by step. And by the end of our session, you're going to have a toolkit of simple rules that turn these complicated-looking math problems into an absolute breeze. You are completely capable of mastering this. Here is our study roadmap for today. We'll start with Section 1, looking at what indices actually are. Section 2 builds our toolkit with the multiplication and division laws. Next up, Section 3 tackles negative and zero exponents, followed by handling the power of a power in Section 4. Once we have those tools, we'll take on the boss level in Section 5, mastering fractional exponents. Finally, Section 6 will send you off with some top tips for your exams. It's a clear, straight path, so let's take that first step. Section 1. What are indices? Building the foundation. All right, let's dive into this. Before we can learn the shortcuts, we really need to know what we're actually looking at. What is an index or an exponent? Honestly, just think of the exponent as something we use every single day, a copy-paste button. An exponent is just that small number written above and to the right of a base number. It simply tells us how many times to repeat that base as a multiplier. So if we have 2 to the power of 4, the 2 is our base and the 4 is our exponent, our copy-paste button. We press it 4 times. 2 times 2 times 2 times 2. That's it. If you see a to the power of 5, it just means a multiplied by itself 5 times. Or 8 to the power of 3 is 8 times 8 times 8. It's just a shorthand way to avoid writing out really long, tedious multiplication problems. Once you see it as just a cloning machine, it totally loses all its intimidation factor. Section 2, Multiplication and Division Laws, the Toolkit Part 1. Now that we know what these numbers actually are, we can start learning the brilliant time-saving shortcuts used to combine them when they share the exact same base number. I love this because it brilliantly illustrates the beauty of math. It's all about balance and logic. Let's look at Law 1 and Law 2. Law 1 is about multiplication. When you multiply two terms with the exact same base, like a to the power of m times a to the power of n, you simply add the exponents together. So a to the 5th times a to the 3rd equals a to the power of 8. Why? Because you're literally just combining a chain of 5 A's with a chain of 3 A's, making a chain of 8. Now look at the flip side. Law 2, division. If multiplying means adding the exponents, then division, the complete opposite action, logically means subtracting them. A to the 5th divided by a to the 3rd equals a to the power of 2, because 5 minus 3 is 2. You're basically just canceling out the clones. Let's test this out with a really quick practice problem. If a to the 5th times a to the 3rd is a to the 8th, what is 2 to the power of 2 multiplied by 2 to the power of 3? I'll give you a quick beat to think about it. Well, did you add the 2 and the 3? If you did, you got 2 to the power of 5. Perfect. You just applied your very first law of indices. Section 3, Negative and Zero Exponents, the Toolkit, Part 2. You know, students almost always tense up when they see a negative sign or a zero floating up there in the exponent spot. But I'm going to show you a secret mechanism that makes these incredibly easy to handle. So, the absolute crucial point is this. A negative exponent has absolutely nothing to do with making the final number a negative value. Scratch that idea entirely. Instead, think of that negative sign as a flip switch. When you see a to the power of negative n, you just flip it by putting it under a 1, making it a fraction, 1 over a to the power of positive n. The base drops down and the exponent becomes positive. And hey, if you already have a fraction, like a over b all to the power of negative 2, that flip switch just turns the whole entire fraction upside down. It becomes b over a to the positive power of 2. It just means take the reciprocal. Okay, your turn. How would you rewrite 3 to the power of negative 2 using our flip switch rule? Take a second. All right, so you see that negative sign, you pull the flip switch, and the 3 drops right to the bottom of a fraction. So it becomes 1 over 3 to the power of positive 2. And since 3 squared is 9, your final answer is just 1 over 9. Great job. Now let's look at Law 5, which is honestly my absolute favorite because it feels like a total cheat code. The zero exponent rule. Any non-zero base to the power of 0 simply equals 1. That is it. It doesn't matter how big, complicated, or scary the base number looks. If it's raised to the power of 0, it all collapses down into a neat, simple number 1. Let's do a quick check just to make sure you actually believe me. What is 100 to the power of 0? Yup, it's exactly 1. If I put 1,000,000 to the power of 0, it's 1. If I put x times y times z in parentheses all to the power of 0, still 1. See? You're building up some serious math confidence right now. Section 4. The power of a power. The toolkit part 3. Let's move on and see how this builds, because now we're going to look at a scenario where an exponent is carrying its very own exponent. This is Law 4. When powers are stacked right on top of each other, usually separated by a parentheses, you do not add them, you multiply them. If we have a to the power of 5, and that whole thing is raised to the power of 2, we just multiply the 5 and the 2. So a to the 5th squared becomes a to the power of 10. Think about why this works. A to the 5th squared means you have 2 groups of a to the 5th. 5 a's over here, 5 a's over there. That's 10 a's in total. Let's practice the stacking rule real quick. What is 2 to the power of 3 all raised to the power of 2? Well, you see the powers are stacked, so you multiply. 3 times 2 is 6. The base stays exactly the same, so your answer is 2 to the power of 6. Look at how rapidly your skill set is growing here. You're handling stacked exponents like a pro. Section 5. Mastering fractional exponents. The boss level. Okay, take a deep breath. We are going to slow our piecing down quite a bit here. This is the part of the exam paper that usually causes the absolute most panic. But remember, we've built a fully equipped toolkit today. You are perfectly ready for this. Before we do a complex problem, we just need to translate one little thing. A fraction floating up there in the sky simply means a root down on the ground. A power of 1/2 is exactly the same thing as a square root. A power of 1/3 is exactly the same thing as a cube root. The number on the bottom of the fraction, the denominator, always tells you what kind of root it is. All right, here is our first boss battle. 625 to the power of 3/4. Looks terrifying, right? But let's just break it down into a manageable staircase. Step 1. Look at the denominator of that fraction. It's a 4. This means we're dealing with a 4th root. Step 2. Because we know it's a 4th root, let's look at our base, 625, and see if we can convert it into something to the power of 4. Well, 5 times 5 times 5 times 5 is 625. So 625 is really just 5 to the power of 4. Let's swap that right in. Step 3. Now we have 5 to the power of 4 all raised to the power of 3/4. Oh wait, those are stacked powers. We know Law 4. We just multiply them. And what is 4 multiplied by 3/4? The 4's cancel out, leaving just a 3. Step 4. We are left with a simple 5 to the power of 3. And 5 times 5 times 5 is 125. We just beat the boss using simple steps. Let's do one more. The ultimate boss level combining multiple rules. 216 to the power of -2/3. Step 1, look at the denominator. It's a 3. So we want to convert 216 into something cubed. Well, 6 cubed is 216. Step 2, swap it in. Now we have 6 cubed, all raised to the power of -2/3. Step 3, power of a power. Multiply the 3's by the -2/3. The 3's cancel out, leaving us with a -2. So we have 6 to the power of -2. Step 4, we have a negative exponent. Remember what we do? Pull the flip switch. It drops under a 1, becoming 1/6 squared. And since 6 squared is 36, our final answer is 1/36. Look at what you just did. You applied the power of a power and the negative flip switch perfectly. Section 6. Top tips for exams. The send-off. You've learned the laws, you've battled the boss levels, and now it's time to arm you with some practical strategies right out of the source material for when you sit down on test day. Here are your ultimate cheat codes for math success. Number 1, always look at the exponent first. It tells you exactly which rule from your toolkit you need to pull out. Number 2, remember that the denominator in a fractional exponent always indicates the root. It's just a root in disguise. Number 3, if you are solving an equation, your primary goal is to make the bases the same, like how we turned 625 into 5 to the power of 4. Once those bases match, the exponents just fall right into line. And finally, number 4, practice is absolutely essential. Math is a muscle, you guys. The more you use these flip switches and shortcuts, the faster your reflexes are going to become. So we've covered the cloning machine of standard exponents, the addition and subtraction shortcuts of multiplication and division, the fraction-making flip switch of negative exponents, the multiplying rule for stacked powers, and even those scary fractional boss levels. My final question to you is this. Which of these index laws are you going to practice first today? Pick one, write out a few simple problems, and prove to yourself that you've totally got this.
Thanks for hanging out with me on this explainer, and happy studying.